Welcome to this chapter on more about solids, liquids, and gases. Now, this chapter mainly deals with the concept of matter. Okay, matter and its properties, especially. Okay, we know that matter is something which occupies space and has mass. Okay, and has weight, or it has mass, right? That is called matter. So, whatever we see around us, books, stones, bus, petrol, water, lunch boxes, trees, people of different textures and nature. So all these things constitute matter. Now, when we talk of matter, we mean every substance in the universe, everything from the tiniest speck of dust, that is also matter, to the largest star, that is also matter. And on the left, you can see that there's a fact file. Mainly, it is the Greeks in the year 500 BC who first believed that matter is composed of atoms. But it was Aristotle, the famous philosopher in 350 BC, who said that all matter is composed of 4 elements. Chatte element diye toiri. That is the earth, air, fire, and water. And this view of Aristotle, especially, this lasted for about 2000 years until the emergence of Sir John Dalton, an English scientist. John Dalton again brought back the idea of atoms, which was prevalent many years ago, right? And it was around 1800 AD, 1800 or so. And he explained the different chemical reactions that take place on the earth by proposing that matter, all matter are actually composed of atoms. Now, Dalton had no idea about how did matter made up of, or how did atoms look like. Although he did not knew how they actually look like, but he knew that if there are atoms, this may point to something which is very much fundamental. That is, atoms make up the building blocks of matter, or atoms are something which build up matter. So everything around us is actually matter. Now matter is made up of numerous tiny particles which are called molecules, and molecules are in turns made up of atoms. Now molecules is something which may or may not exist independently. So exactly the definition of molecule, if I say, I can write it like this: molecules are the basic building blocks, sorry, they always exist independent, blocks of matter which always exist independently. So molecules are the basic building blocks of matter which exist independently, but atoms may or may not exist independently. সব সময় যে independently exist করবেই এরকম কোনো গ্যারান্টি কিন্তু কোথাও নেই. Okay, that is the difference between these two. For example, you can consider that a drop of water is made up of millions of molecules of water, H2O. A molecule of water in turn is made up of 2 atoms of hydrogen and 1 atom of oxygen. So water is made up of numerous atoms of oxygen and hydrogen. So this implies that just like the bus, books, water, everything are actually made up of atoms. So there are so many different things around us. Imagine that all are actually made up of atoms. Now these atoms may be of different shape, size, and may have different properties altogether. Okay, and these atoms may or may not exist independently. So just write it down over here. So atoms may or may not exist independently, and because of that many atoms might combine to give two or more atoms. Okay, and two or more atoms may form a molecule, and then we call that molecule as diatomic molecule. Sometimes it may so happen that three or more atoms, three atoms combine to form a molecule, then we call it as a triatomic molecule, right? So atoms reside inside molecules, and you will be shocked to know that you are also made up of atoms. Okay, now our body, in biology you have learned that the human body or every living organism is made up of cells, and if a cell is broken down, you will find that the cell is made up of many chemicals, and these chemicals are nothing but are a combination of elements like carbon, oxygen, sulfur, phosphorus, and these elements are again made up of atoms. So you can understand that all living things around us are simply an organization or a collection of atoms. In order to understand the nature of these atoms, the arrangement of these atoms in a substance, it is essential for us to understand the kinetic theory of matter. So first we'll go into this kinetic theory of matter just to understand these concept of atoms. Okay, so let us see what does this theory actually tell us about atoms. Well, this kinetic theory was published in 1860, and kinetic theory of matter is the most widely accepted theory about the behavior of matter. Okay, and this theory says that all matter are actually made up of atoms, but with a variety of arrangements and different motions. And the main points that the kinetic theory of matter says are like this. That is, all matter is actually made up of atoms or molecules. The smallest molecules are of the order of about 10 to the power minus 10 meter in size, and these molecules that we are talking about, they are constantly moving. They're in constant random zigzag motion, and they possess kinetic energy due to their motion, right? So the molecules which we are talking about, they are not fixed, they are not constant, but they continuously move about here and there, and they also have kinetic energy. And the kinetic energy of these molecules are also directly proportional to the temperature of the substance. So greater the temperature of the substance, greater will be the kinetic energy of the molecules. Okay. And there is always a force of attraction that exists between the molecules of matter, so which is called an intermolecular force of attraction. The force that exists between similar kind of molecules is called the force of cohesion, and the force that exists between different kinds of molecules is called the force of addition. For example, the force of attraction between water and glass is called the force of addition, but the force that exists between two water molecules is called the force of cohesion. Okay, if you pour water on a glass or a window pane, then you will see that some water droplets continuously get attached to the window pane, and they do not fall away right off. Okay, and therefore the window pane gets wet. Okay, so because the water molecule that actually falls on the window pane binds itself with the glass molecules, and they mutually attract each other by a force which is called the force of addition. Okay. And the space between the molecules of a substance is actually called the intermolecular space. Okay, so it is the intermolecular space. And kinetic energy, you understand, kinetic energy simply means the energy that is possessed by a body due to its motion. Okay. Okay, let us go to this fact file. So due to increase in population and other materials, every year increase the total mass on the earth. So is it so? So with increase in population and with increase in other materials every year, does it increase the total weight or total mass on the earth? It's not so. Surprisingly, it is no. Why? Because the atoms that make up our body and other materials are probably the same atoms that were here before we are born. So it is atoms which make us. They are believed to be recycled among the living and the non-living forms on this earth. It is quite impossible that the atoms in your body were once part of Galileo's brain or of a dinosaur's leg. So that means the atoms that you have, they are continuously recycled in nature. The atoms do not actually change. Only the form changes. The atoms continuously get transformed from one form to the other. Doesn't it sound very interesting, right? So it's amazing. So when some organism dies, the atom is recycled into some other forms. Okay. And hence this actually happens. Number 7, the intermolecular force of attraction is less when the intermolecular space between the molecules is large. So here the intermolecular attractive force is quite less when the intermolecular space between the molecule is large over here. Now, this means that greater the distance between the molecules, lesser is the force of attraction between them, and more and less the intermolecular space, more is the intermolecular force of attraction, which is very clear. So if the atoms are closely spaced, they attract each other with a lot of force. If they are widely spaced, they do not attract each other with so much force. And depending on the arrangement of molecules in matter, the force of attraction between the molecules, now the intermolecular space, how much intermolecular space is there inside it? Okay. How much is the force of attraction between the molecules? So based on these conditions as to how much is the force of attraction between the molecules and how much is the intermolecular space between them, molecules are classified into 3 categories: solids, liquids, and gases. So let us read about each of them individually. Now let us talk about solids. Now if I talk about solids, you simply have a look at your pencil box. It is a solid, right? And solids have got a definite shape, it has got a definite volume. And in case of solids, they are absolutely very much tightly packed, because these solids have got a very strong force of attraction between them. So since they are tightly packed, so the molecules are very close to each other, the force of attraction between the molecules is very strong. So the intermolecular force is weak, intermolecular force is very strong, and the intermolecular space is very small. Therefore, it is very difficult to actually break a solid, because a solid is very rigid. Rigid because why? Because the intermolecular force of attraction is very strong in case of solid. In case of liquid, example, take a glass of water and you empty the pan and pour the water in the pan from the glass. So first you take some water in glass, and then from the glass you pour the water in the pan, say frying pan. You will see that the shape of the water changes according to the container in which you keep it. In the glass, it takes the shape of the glass. In the container, it takes the shape of the container. That's why we say that the shape of liquid is not fixed. It takes the shape of the container in which it is kept. But the volume that is occupied by the liquid, volume means the amount of space that is occupied by an object. So I write the definition. Smalls, so volume is the space occupied by an object. Okay, so volume is actually the space that is occupied by an object. So the volume that the liquids occupy, it is quite it remains the same Doesn't matter whether it is kept in a glass or whether it is kept in a pan. Okay, so it has got a definite volume but not a definite shape. Now you will see that if you throw this water on the floor, the water spreads on the floor. মেঝেতে যদি ফেলে দিই ছড়িয়ে যাবে. So this shows that the intermolecular force of attraction is comparatively weaker in case of liquids than in case of solids. It's not that strong because water can actually flow somewhat. Okay. Because of this, if you heat liquids, they expand more compared to solids. So this is which is known as thermal expansion. So thermal expansion is a phenomenon in which if you heat a material, it will continuously expand. Okay. So since these liquids have got a definite volume, they cannot be compressed very easily. Now coming back to gases. Okay. So if the compress means you cannot make it have in a, or you cannot confine it within a fixed volume that you want. You cannot do that because liquids have got a definite volume. So you cannot compress a liquid. Basically, চেপে রাখা যাবে না. You cannot pressurize the liquid and put it inside a container. Okay. Now coming to gases. Now in case of gases, the molecules are very loosely packed. As you know, the force of attraction is very weak and the molecules drift apart here and there. And the mobility of the molecules is the highest in case of gases. This means that the intermolecular force of attraction is very weak in case of gases, weaker than liquids, and hence they can move very easily. For example, petroleum gas, which is compressed, the LPG, the liquefied petroleum gas, is compressed and fitted inside the cooking gas cylinders, which we use in the kitchen to cook our food. Gases can be compressed to any volume that you wish to. মানে একটা ছোট্ট সিলিন্ডারেও রাখা যাবে, একটা বড় সিলিন্ডারেও রাখা যাবে, আর একটা একদম ছোট সিলিন্ডার সেটাও রাখা যাবে, because they can be pressurized and compressed. Okay, which you cannot do with liquids and solids. Okay. Now there's an interesting question over here. Very interesting. If we burn an incense stick, that is agarbatti, or open a bottle of perfume at one corner of a room, you will see that within a few minutes, the perfume, the smell of the perfume spreads to all corners of the room. Why is it so? Simple reason is that the molecules of the agarbatti or the molecules of the scent, that continuously spreads to the other parts of the room, simply because they are the molecules of a gas, and the molecules of a gas can move about freely in space, and hence within few moments you can smell the scent or the agarbatti or the incense stick at another corner of the room. Okay. Coming to the force of cohesion and adhesion. Now, what is this force of cohesion and what is this force of adhesion? So I just told you that if you dip, just here as the example is given. So if you dip a wooden pencil in a glass of water, you will actually find that the wooden pencil gets wet. That means drops of water get attached to the pencil. Okay. Now when another pencil is dipped in a glass of mercury, very interesting, mercury te jodi arekta pencil dobano hoy, after you take it out, it does not seem wet. Simply, you will not find any single mercury molecule getting attached to the pencil. Once more I'm telling, you take a pencil, you dip it in glass of water, you take out the pencil, you will see it is wet, bhije geche. Okay, because water molecules stick to the surface of the pencil On the other hand, if you take a pencil and dip it in mercury, you understand, mercury, and then you take out the pencil, you will not find a single drop of mercury on the surface of the pencil. Why is it so? Simply because water molecules get easily attached to the molecules of the wood. On the other hand, the molecules of mercury do not easily attach with the molecules of the wood on the pencil. This difference gives rise to these two different phenomena, which is known as the force of adhesion and the force of cohesion. And the strength of this force depends on the kind of molecules which are present. So here, the adhesive force between water molecules and the wood is greater than the cohesive force among the water molecules. But in case of mercury, the cohesive force of mercury is quite greater, or the force of cohesion of mercury is quite greater than the force of adhesion between mercury and the wood. So since the force of cohesion is greater, so the mercury molecules are held together and no mercury molecules get attached with the surface of the wood. Okay. So this force of cohesion also works between molecules of wood, paper also, same way. Okay. So if you actually take wood and if you keep it on paper, so will the wood get attached with paper? No, is it not so? Simply because of the force of cohesion. So here the adhesive force between water and wood, very interesting, is much greater than the cohesive force between the water molecules itself. So because of this, the molecules stick to the pencil. Okay. Now we have just read that molecules of a substance are attracted to one another due to the cohesive forces between the molecules. Now, if you have a jar which is full of a liquid, say water, a molecule in the middle and it has other molecules around. Okay. Now, if you consider that if I have a jar which is full of liquid, say the liquid is water. Now, if you consider that there is a water molecule in the middle of the jar, obviously that water molecule will be surrounded by other water molecules from all directions, right? Simply because of this. Just I can show this by this circle. So if this is a water molecule, so surrounding this there will be other water molecules as well, right? Several other molecules, and all these water molecules will have an attractive force. So all these water molecules will actually attract each other, which is called the cohesive force, right? So it experiences cohesive force from all directions. Shop direction theke kintu cohesive force experience korbe, right? But the molecules which are at the sides, mane if I have say কিছু মলিকিউল আছে যেটা মিডলে থাকে আর কিছু মলিকিউল আছে যেটা সাইডে থাকে. So there are some molecules which are inside and some molecules which are at the sides. Now you see one thing. Now at this surface there is no other molecule above it. Here you see এই যে মলিকিউলটা আছে দুদিকে দুটো মলিকিউল আছে, and all these two molecules try to attract this molecule towards itself. একে অপরের সাথে attract করে, right? So they attract each other. But the molecules which are at the side over here, these do not get actually attracted. এটা কিন্তু অ্যাট্রাক্টেড হয় না, বিকজ এই মলিকিউলের পাশে কিন্তু কোনো মলিকিউল নেই. এই মলিকিউলের একদিকে মলিকিউল আছে, এখানে মলিকিউল আছে, এখানে আছে, এখানে আছে, কিন্তু এদিকে কোনো মলিকিউল নেই, বিকজ দ্য সারফেস এন্ডস ওভার হিয়ার. দ্যাট মিনস হিয়ার যে মলিকিউলটা পাচ্ছে সেই মলিকিউলের সাথেও অ্যাটাচ হয়ে যাচ্ছে, মানে এইটার বাইরে এক্সটার্নালি যদি কোনো মলিকিউল থাকে, সো what happens is that সিম্পলি এ এর সাথে অ্যাট্রাক্ট হয়ে যাচ্ছে বা লেগে যাচ্ছে, অ্যাটাচ হয়ে যাচ্ছে। বাট এখানে কি হচ্ছে, ইনসাইড দিস চারপাশে অন্যান্য মলিকিউল আছে which are attracting it towards each other, so they are attracting it towards each other. But here you see এখানে তিনটে মলিকিউল আছে চারপাশে, কিন্তু এখানে কোনো মলিকিউল নেই, so it experiences the net force along with this molecule, right? In this happens in case of water. So this is called the force of cohesion. Okay. Okay. Now there is another phenomenon which we can understand, which is called the force of, or which is called the phenomenon of surface tension. Okay. Now this will explain how does this cohesive force act on these molecules. এই যে মলিকিউল গুলো আছে, এই মলিকিউল গুলোতে কোহেসিভ ফোর্স কিভাবে অ্যাক্ট করে, how does it actually act, how does the force between the individual molecules are actually acting, right? That we will be seeing. So let's just read it out. So have you ever tried placing a razor or a needle gently on the water surface? Okay, so razor or a needle on the water surface, so does it float or sink? Surprisingly, if you try to keep it gently, it will actually float due to the property of the liquid surface, which is called surface tension. So if you keep a razor or a needle gently on the water surface, it will actually float. Very interesting. Let us understand how it happens. So in the figure 4.2, as you can see this figure, the molecules that are down in the liquid, মানে এই জায়গাতে, they experience cohesive forces from the neighboring molecules on all sides. Thus the forces balance out. মানে মাঝে কোনো একটা যদি মলিকিউল থাকে তো তার চারপাশে কিন্তু অন্যান্য মলিকিউল আছে, so there are four other molecules surrounding it. For example, I already draw that. So this is the molecule at the middle. At its four sides there are four other molecules, and these molecules continuously attract each other, attract this molecule. A কে attract করছে, A কে attract করছে, A কে attract করছে, A কে attract করছে, and hence the net force acting on this balances out everything. So the forces get balanced, right? Now as a result of this, due to the balancing of force, the net cohesive force acting on this gets balanced. But the molecules which are at the surface যেগুলো আছে, they do not experience a balanced cohesive force. Okay, simply because they are at the sides, at the edges. সেটাই হচ্ছে মেইন কারণ. Okay. So, however, at the surface, the molecules have no liquid molecules above them. কিন্তু সারফেস যদি হয় তাদের উপরে কিন্তু কোনো লিকুইড মলিকিউল নেই। এইখানে যে লিকুইড মলিকিউল গুলো আছে এদের উপরে কিন্তু কোনো লিকুইড মলিকিউল নেই। So hence the net cohesive force that acts on the molecules is sideways, শুধু সাইড থেকে অ্যাক্ট করে, but nothing from the top. Okay, and downwards, মানে simply if this is the surface আর একদম এই টপে এখানে কোনো মলিকিউল আছে, তো এর উপর যে কাজ করবে, এখানে একটা মলিকিউল আছে, এখানে একটা মলিকিউল আছে, এখানে একটা মলিকিউল আছে। So on this molecule there are three molecules which are acting. এইটার সাথে অ্যাট্রাক্ট হচ্ছে, এটা এর সাথে অ্যাট্রাক্ট হচ্ছে, আর এটার সাথে এ অ্যাট্রাক্ট হচ্ছে। So there are only three molecules to attract this molecule, but there is no fourth molecule above this molecule in order to attract it. Attract করতে পারছে না. That is why the cohesive forces do not get balanced. Balance হচ্ছে না কিন্তু, ঠিক আছে? So because of this, the molecules on the surface experience an overall force pulling them inwards. So মনে হয় যে as if, so ultimately sideways যে আছে ফোর্সটা, sideways এ কিন্তু ব্যালেন্স হয়ে যাচ্ছে, সাইডে দুটো মলিকিউল আছে কিন্তু নিচে যে মলিকিউলটা টানছে ওকে ভেতর দিকে, there is no molecule on the upper surface or there is no molecule above this molecule, এর উপরে কিন্তু কোনো মলিকিউল নেই যে একে ব্যালেন্স করতে পারে। So these molecules experience a resultant force inwards, ভেতর দিকে, pulling them inwards, keeping the molecules and the surface together. Due to this pull, the surface tends to occupy a minimum surface area. তো সারফেসটাকে নিয়ে ইনার মলিকিউল গুলো পুল করে। So as a result, the surface of the water occupies a area which is very small, minimum surface area. And due to this pull, the surface tends to occupy a minimum surface area and the surface contracts and behaved like a stretched elastic membrane. যেন মনে হচ্ছে কেউ টেনে ধরে রেখেছে water surface-টা। This property of the liquid, okay, to contract its surface area due to the intermolecular attractions is called surface tension. Now let us understand or look at an example to make this concept more clear. First, you take your paint brush, okay, and dip it in a glass of water. So this one. So take a paint brush, dip it in water, look at its hair. So this is a hair actually, okay. Take your paintbrush, dip it in a glass of water. So this is the paintbrush, dip it in glass of water. Now again look at its hair. Now slowly take the brush out of water and look at its hair. So slowly you take it out and now look at the hair. You will see that it has contracted. You can see a difference. When the brush is underwater, the hairs are fluffed, right? ছড়িয়ে থাকে. But when the brush is lifted out, the surface film of the water contracts, right? যেই এটা উঠিয়ে নেওয়া হচ্ছে, water film contracts due to the surface tension. এই জন্য hairs গুলো একসাথে চলে আসছে. It pulls the hairs together. So this is a beautiful example which illustrates surface tension. Okay, now another one, you can see this figure 4.3b. Okay, the simple concept of water droplets being spherical. So spherical water droplets. So when you will see that when raindrops fall on the leaves or on a surface, you will see that the droplets of water look like a sphere. So can you tell why is it so? Why are the water droplets spherical and why not they are rectangular? Why not they are triangular? Why not they are of any other shape? Simply because of surface tension. Why? Because molecules, you see that the molecules on the inside are pulled in all directions. সব দিকেই কিন্তু ভেতরের দিকে pull করে. Okay. Now, the water, the molecules which are at the surface, all the molecules are actually pulled inwards, যেটা surface এ আছে. So thus the molecules on the outside, বাইরে যে molecule গুলো আছে, they tend to move inward to form a shape which has the least surface area. And in higher classes you will understand that sphere has got a least surface area out of all the geometrical figures. So the geometrical figure that has the least surface area is a sphere. Therefore water droplet is spherical. Okay. And another effect that is seen in liquids due to cohesion is the shape of the meniscus. Meniscus is the shape of the surface of the liquid in a capillary tube. Okay. So this is called the shape of the, this is called a meniscus. Okay, the shape of the surface of the liquid. So when any liquid is taken in a container, a curve is formed at the surface of the liquid due to the surface tension. So this curve is called a meniscus. And there are two types of meniscus. One is a concave meniscus and the other is a convex meniscus. কোনটা কেন হয়, কি জন্য হয়? Let us try to understand. Water has a concave meniscus, mercury has a convex meniscus, simply because of surface tension. Why is it so? Let us understand. So when water is poured in a glass jar, so এখানে water যখন pour করা হচ্ছে, you see that the adhesive force of water is greater than the cohesive force. Therefore, the water molecules get more attracted near to the glass molecules. So water molecule glassের দিকে বেশি attracted হয়ে যাচ্ছে. But in the middle, their attraction between the water molecules, that is the force of cohesion, is very small, but force of addition is very large. সেই জন্য water molecule গুলো বেশি এদিকে attract হয়ে যাচ্ছে, তাই জন্য এই শেপটা এখানে বেশি হয়ে যাচ্ছে, মানে এখানে ওয়াটার লেভেলটা বেড়ে যাচ্ছে আর এখানে ডিপ করে যাচ্ছে। On the other hand, the reverse happens in case of mercury. In case of mercury, the force of addition is small, but the force of cohesion is much greater. So because of that, because force of addition is actually less, so over here at this point, the level of the mercury dips at the glass mercury interface. But at the middle, since the cohesive force of mercury is greater, the shape of the mercury is bulging out over there. So it is called a convex meniscus. Okay. Very interesting. Can you weaken the surface tension of water? Yes, the answer is yes, you can. And how do you do? By adding soap to water. How is it so? So what happens when you add a soap to water? You weaken the surface tension of water by adding certain kind of impurity. So soap acts like an impurity over here because it has got something, or it introduces certain molecules which is not same as water. So the molecules of soap get in between the water molecules, and because of this, the strong cohesive forces which exist between water molecules, they are broken. So surface tension is reduced. So water can go through the clothes easily and clean them. So easily it can pass through that. And hot water has less surface tension than cold water, because if water is hot, because the force of cohesion between the water molecules breaks. So because of that, it cleans clothes better. And we must understand that surface tension is more noticeable in water than in any other liquid. Okay. Surface tension also helps us in many ways. It has plenty of applications. How? Let us understand. The surface tension of our urine is decreased if the amount of bile in it increases. So if the bile in our urine increases, surface tension will decrease. Why? Because in water, certain impurity is coming in. So this forms the basis of the Hay test, which is a test in jaundice, just to indicate whether we are having bile juice in it or not. So in the Hay test, sulfur is sprayed on the urine surface. Sulfur, if the amount of bile in urine is normal, sulfur actually floats on it. Otherwise, it sinks if the surface tension of urine is lowered by the bile. Okay. Now there are disinfectants that we use to kill the microbes, and usually solutions of low surface tension, and this allows them to spread out on the cell walls of bacteria and disrupt them. Okay. So this was about the part of surface tension that we have read. And the last portion, have you ever wondered why hot and cold soup taste different? Some understanding. Let's see. Hot water has less surface tension, right, than cold water. Now this allows the grease or oil in hot soups to float in little bubbles on the surface of the soup. So bubbles can actually float on the surface. Now when the soup cools, surface tension of water increases, so the grease or oil is dragged out over the surface of soup and the soup becomes greasy. Okay. Hence hot soups taste different from cold soup. So because of the presence or absence of the grease, okay, more amount or in less amount, okay, that changes the taste of the soup that we have, grease or oily part of soup. Fine. Right. So we'll keep it up to here. And in the next day, in the next lecture of on physics, we'll continue with the remaining portion of the chapter. Okay, thank you so much.